Hi everyone! In this video I'll introduce the Hamilton Jupyter Notebook extension. I'm very excited about it. It's a great experience to define pipelines, data flows, LLM applications from the notebook, and you're not sacrificing code quality for this experience. You will see how you can define your data flow in the notebook via regular Python functions, view how these functions create a data flow in your notebook, and then execute it from that interface. Then we can cleanly move that code from the notebook to Python modules where you'll be able to commit them and version them with Git and use them in productions later on in the lifetime of your data science projects. We will mostly cover toy examples, but I'm sure you're going to be able to see how it applies to your real day-to-day work. So let's start with a refresher on how Hamilton works. It starts by separating the concerns of defining a data flow being interchangeable with data pipelines, and executing that data flow. To define a data flow, we have several nodes, and you have to connect them. How do you do that in Hamilton? You have the function name that defines the name of the node, and the return type of the function defining the return type of that node. So in this case, we have joke prompt, which is a string. And then we have another node that's called reply. And via its parameter names of the function, it specifies what it depends on. So it depends on joke prompt, which is a string. Reply being a string. Punchline depends on reply. And it also returns a string. It's a very simple data flow, but what's interesting here is that you see there's no import of Hamilton. It's just regular Python code. Then you have the run.py, where the Hamilton code lives and where your data flow is imported. This is the file that was right next to it that I just showed you. So we import the Hamilton driver subpackage, and we use the builder object. The builder object has a with modules clause. It takes the data flow, we build the data flow, we build the driver, and we get the driver. Here I have a function that's called, a method that's called display all functions, and it will create a file on disk that's a picture of the data flow. And with the driver, we also have execute, where I can request the node punchline by name and get its result. I will print this result. So if I go to my terminal and I say python run.py, I have the punchline no cow say moo. And I have the visualization for it. But the separation between these two files can be hard to deal with and might slow you down in some instances when you have many files and you want to reduce the sprawl as much as possible, especially when you're experimenting. So one approach is to move that code to dataflow.py. What we will do is make this logic appear under the if name main, which is a standard way of defining scripts in Python. So everything above it will be imported as part of the data flow, and things in the if clause will only be read at execution and therefore don't constitute definition of nodes. You see, I'm importing data flow, but it's the name of the current file. This is valid in Python, but if you want to be extra safe, you can say main, which will refer to the current file. And so we will build our data flow with main. Now I'm executing Python data flow. I'm going to delete the picture just to show you that it works. So all of this can be done without the Jupyter Notebook, but it might be a bit cumbersome if you need to iterate very quickly or you want to interact you want to interact with the results. Another thing you can do is python -i dataflow.py, which runs in interactive mode. And we will actually enter this section. So I can say print the results and have the dictionary. So this is very interesting if you want to do things like, I don't know, display all functions, dag.pdf. It should produce a PDF. So now I have a PDF produced. Again, this is all possible without the Jupyter Notebook. But the Jupyter Notebook does help. And I'll introduce first the concept of cell magics and line magics. In short, a cell magic or a line magic are both Jupyter and IPython constructs, and they're like decorators. So they transform how the whole line of your cell will be executed or the whole cell. We will use that to our advantage to create Python modules, so include these functions in a cell in the notebook. To import an extension in Jupyter, you need to start with the line magic load extension, and here it's a regular Python import. It's the plugins subpackage and then the Jupyter Jupyter magic module, or you can have reload, they do the same. So we start by doing that, and then you can always call, now cell2 module is available, and we can add a question mark to get to its documentation, its docstring. But I will guide you through all of that right now. So the basic is that creating with cell2 module, adding the cell2 module magic will create a module in your current cell. So here we have a module that's named joke. That will be the name of the module, and the -d argument or -display will make it visible on the output. This is cool. We can access the joke module if we go to joke. We'll say it's a module. It's located in a temporary place. And we can use the functions either directly, we have joke prompt, or we can access the joke prompt function through the module. Then one thing that's important to note is since this defines an entire Python module, you need to have all of your required imports here. So if I don't include this statement, it will throw me an error. It will say blah, 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 blah. Name optional is not defined. Named optional being this, that's called here. If I do this, now there are no errors. So to display, as I explained, you can just add -display. There are some short form arguments. As you add more arguments or become familiar, this can help. It does exactly the same thing. And you can pass a configuration. If you haven't used that before, it allows you to shape a few things for the visualization. In this case, we will have the orientation from top to bottom. And we pass this is a variable, and we pass it after the display argument. Now we have the same visualization, topic and joke prompt from top to bottom. And here was left to right. So you can write a module to a file, which is interesting when you want to make sure that the code you've defined and worked hard on will live and not die in that notebook. So you just add the write to file, or you can have short form W. And now we have a joke.py. It takes the name here, and it will create it. We can always pass an explicit file name, so I can say jokes. Now we'll create jokes. But be careful when using that feature because it might override things that exist already. I will just run that again. Just to show that it works, we can import it now from the file. So we can configure a driver because sometimes you're using config when, and you want to pass values for that. Here we pass a config via a JSON of a dictionary. If you're not familiar with all like the intricacies of Hamilton, don't worry, but I'm just putting it out there. So if you're using configs, you can do that with the -config argument. And you will see the config appear, and you will have the value that it specified. You can also specify it with the equal sign. But in this case, that means that everything on the right will necessarily be a string, which might be restrictive in some cases. If you want to support the full array of Python types, you can use a variable, so here my config, and pass it after the config argument. Again, oh, I didn't execute this cell, and now it works. I could say true in that case. Just to show that it's not constrained to strings. Now we have the value true appearing. So building a driver. So if you want to do more complex things, maybe you can build a driver, as we showed previously. Build a builder, create a builder. You have the builder that you're familiar with, but you don't have the build clause. So if I remove it and I check the type of this object, it's a builder. So now I can do -b, -builder, and pass it the variable myBuilder, and it will work. In that case, we're using parallelizable and collect nodes, and we're also using a config. As you see, the config that's specified in the with config was used because there's no --config parameter passed. Now, a very nice thing when you want to experiment or debug maybe a module is to create a builder that has an imported file. So here joke, well, let's call it jokes. Give me a sec. Write to file jokes. Just so we're clear that it's not the same joke as before, the one that was defined in the cell. So this is called joke. But now we will be importing jokes. Now we're passing a builder that has the module jokes, and we can extend it. So if I was just to say like pass, I don't know. See, so now I have nothing defined. I cannot run an empty cell, by the way, because it will say it's empty. But if I say pass, it will show the builder, everything that's in the builder. So this is a jokes module that I imported. But then it's nice because I can extend it. See, so the jokes module is passed to the builder. The builder is passed to the cell, and the cell can add functions. So jokes only define joke prompt. And here I'm using joke prompt and I'm creating joke response. Hoping this is clear, but this is very powerful when you have maybe like, you could have something like cell to module, model evaluation. You're working on the evaluation of a machine learning model, and your driver, well, your builder could have like the data preprocessing, model training, and then you could view all of that in a single visualization here in your notebook. Another thing that's cool is we can take here like jokes.py and copy it directly in our notebook if we want to interact with the content of that module. So here we created a new cell that has a joke prompt that's defined here. You can say, well, we were actually looking at jokes. You can say, I will add a doc string just to prove you from jokes.py. See, and it takes in the modifications. Now, what's exciting is so far we've only defined data flows, but you can also execute them directly in your notebook, and this is very powerful. So before we showed that you can, yes, create a cell, well, a module in a cell, and then you can import it directly. So with modules, execute results. This is very similar to the script approach that we had. What if you could do all of this in a single cell? So here we just add -execute. And here I'm adding a data frame just for the sake of it. We will see the visualization, and in yellow you have what is called or requested by driver execute. So we see that all the nodes are requested and they're all printed by default. So this is great because you can see it's in topological order. So you can see that the joke prompt, knock knock, who's there? Cow say, reply, call say who? No, cow say moo. Great joke, by the way. So this can be very useful when you want to execute things quickly and see what result they produce. One thing that's nice too is if you want to debug, you can always run it like that without the display and you can quickly execute it. Or another cool approach is to, this is very crowded, I have too much zoom. I want to say split on the right. I hope this is not too small, but what's cool is I can do display. And while I'm viewing this here on the left, I can add functions. And like it shouldn't budge too much punchlines. And here I can keep adding to the module. It will push it down slightly, but I can see how the visualization evolves as I'm adding more code. Okay, so there's that. I will clear all outputs. Okay, but when you want to execute the data flow, it's nice to execute everything, but you might not want to execute everything. You can reduce the number of variables executed by passing some variable that is a list to execute. In this case, we only want reply. And we'll see that it trimmed the data flow and only executed up to the reply node, which is exactly what we wanted. And it printed only the requested node. So reply is equal to cow say who. Then inspecting results. So how do you access these results? Well, here I will hide the results, which is an option. They're no longer printed. But you can access them directly. So this is very cool. We inject the result of these nodes and we match their node name to variables in the notebook space. So if you just print punchline, you have the variable. And if you say reply, you also have the value. This is great because previously I defined a data frame and it's there. And I could say like fill NA, 0. Well, in this case, I don't have no values, but this is cool because you can directly inspect things and interact with them further. Another cool thing, now my variables are probably messy, but in VS Code and in Jupyter, you have a variables view. And you will see all the things that have been executed. Remember punchlines with 3 S's? Well, it's a variable and it's accessible by name. And for more complex things, you can just click here, for example, and see the content of the data frame. So if I was to change, I will add a row essentially. Well, yeah, this has execute. Now I refresh and it has the extra row. This is very powerful as you're doing things interactively, and when you're done and you're satisfied with your code, you can always say write to file. And now we should have a joke.py that has all of these functions. So this is a lot to take in. I'm sorry if I'm going fast, but I hope you see how it can help you in your workflows. You see here there's ways to pass the inputs and the overrides that are standard Hamilton constructs. So we just pass dash inputs with a variable, dash overrides with a variable. These variables must be dictionaries. Didn't execute this previously. And now the topic is passed as Monday with a lowercase letter. And I'm overriding the punchline to be bingo bongo. So we see the override legend and the override for the punchline, and things are properly displayed. You can also add adapters, which are very cool. You could even use the Hamilton tracker and track your notebook execution with the Hamilton UI, or use the cache adapters that we have for even faster notebook execution. So now we're just I'm going to add the simple print line. We have a builder called myBuilder that has the print line adapter. We pass builder with the variables myBuilder. And now we will have information for each each node being executed. Sorry. This was very fast. You see it's in the microseconds, but if you have something that runs and it takes a long time, it's nice to have here a sense of where you're at in your execution and see maybe if things are stuck. It will say status failure if there's anything that goes wrong. And there's also a progress bar that's available for adapters that can be nice to have in your notebooks. There's also the Python debugger that's available. So I hope you get to explore that. I hope it's useful to you. And if you encounter any bugs or you have any questions, feel free to reach out to us on Slack. We think this is cool, but it's even cooler if it's useful for you. So make sure to tell us if things go well or things don't go well, and we'll make sure to improve the solution over time. Thank you.